Lesson 91, Video Part 1. Okay, so let's start things off with some fraction multiplication. So please open your workbook to Lesson 91 and find Part 1. In there you'll see 3 different problems. You're going to write the answer to each problem and complete the statement to show if the fraction you end with is more than or less than the fraction you start with. So let's read problem A. 6/5 times 9/8. We have 6/5 times 9/8. What fraction are you multiplying 6/5 by? You are multiplying 6/5 by 9/8. Right there. Is 9/8 more than 1 or less than 1? 9/8 is more than 1 because the numerator is bigger than the denominator. So you will end with a fraction that is more than 6/5 because you are multiplying by a number that is more than 1. Okay, let's read problem B. 3/7 times 5/4. 3/7 times 5/4. What fraction are you multiplying by in this equation? You're multiplying by 5/4. Is 5/4 more than 1 or less than 1? 5/4 is more than 1 because, again, it's a top-heavy fraction. The numerator is bigger than the denominator, just like here. So will you end with more than 3/7 or less than 3/7 when you multiply by 5/4? You're going to end up with a number that is bigger than 3/7 because you're multiplying by a number that is bigger than 1. It's more than 1. So is 6/7 more than 1 or less? Next one. 9/4 times 6/7. We have 9/4 times 6/7. What fraction are you multiplying by on this one? You're multiplying by 6/7. And is 6/7 more than 1 or less than 1? 6/7 is less than 1 because the numerator is smaller than the denominator. It's not a whole number yet. It's only 6 out of 7. So the number you're multiplying by is going to be bigger than the answer you get when you multiply. So you'll end up with an answer that is less than 9/4. So I would like you to go back and write the answer to each problem. Don't simplify, just do the multiplication. Below, complete the statement to show if the fraction you end with is more or less than the fraction you start with. So pause the video now to do the work. And here is how you should have solved. You know that this would have equaled 54 over 40, meaning that 6 over 5 is less than 54 over 40. Like we said, because you're multiplying by a number that's bigger, you know the answer is going to be greater. Next one. This would have been 15 over 28, meaning that 3/7 is less than 15/28. And the last one. 54 over 28, meaning 9/4 is greater than 54 over 28. There's your answers. All right, let's switch gears into balance beams. Remember in last lesson when I introduced to you balance beams? So give me a second to create this. So you have 1 here, 10 here. 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What goes in the middle of the triangle or in the balance? 0. That's our 0 scale. So I'm going to add a weight to here. Oops. I'm going to add a weight on the 5 on the left side and a 7 on the right side. And this line shows the distance to each weight. So you learned that a balance beam will balance if the total distance on each side is the same. So on the left side, we have 5. On the right side, we have 7. Remember, this is left, this is right. So, is the distance the same on both sides? No, the distance is not the same on both sides. Which side has a greater total distance? The side that has a greater total distance is the right side because it has 7. It has 2 greater than the left. So, which side will go down? Which side will weigh more? This side, it's greater. So, it's going to go down, like so. Down on the right side. Now, I'm going to add a weight. I'm going to put a weight on 2. So, how much distance did I add on this side? I added 2 more on this side. So I have a 5 and a 2. And here I still only have a 7. So if I add 2 to this, what do I have on the left side now? I have 7 now. And this is still 7. So which side is going to go down? The left or the right? Neither is going to go down. It's a balanced scale. Even though I have 2 here, it adds up to 7. And this is still a 7. So it's actually going to stay balanced. So please find part 2 in your workbook. For each balance beam, you're going to add 1 weight to the side that has the less distance. You'll make the total distance the same on both sides. So you're trying to keep the balance beam balanced so it doesn't go down on the left or the right. So for problem A, add 1 weight so the distance on both sides are the same. So on problem A, on the left side, there is a weight on the 5 and the 3 mark. So what would you need to add on the other side, right? Or add on a weight onto the other side to balance it out. So what's 5 plus 3? 8. So you would only need to put a weight on the other side. So on yours, on problem A, you have it on the 5 and the 3. So to balance it out, you only need to put it 1 right here. So you have 8 and 8. Next one, problem B. On the left side, you have it on the 2 and a 1 and a 3 and a 4. So on this side, you have 7. Here, you only have 3. So what do I need to add? 4. All I need to do is put a weight on the 4. And now I have 7, just like so. Problem C. On the left side, you have 6 and a 1. And on the right side, you have a 2 and a 6. All right, so on this side, you have 6 plus 1, and on this side, you have 6 plus 2. So all you need to do, because right now, you have 8 and 7. This is the heavier side, so you just need to add 1 more on top of the 1, giving you 8. let you do problem D on your own. All right. I'm gonna switch gears again. We're gonna move into mixed number operations with unlike denominators. We're getting things a little more complicated because you're getting so good at this. So, here's a new kind of mixed number problem. 2 1/5 plus 4 2/3. We can't add the fractions the way they are written, so we find the lowest common denominator. So you can't do this right now. Can't work if, let me make that a little easier for you, if denominator are not the same. We know this. Bad. Okay, so what we need to do is make them the same by finding the, we need to find the lowest common denominator. So, we can't add the fractions because 1/5 and 2/3 can't be added together, so we'll find the lowest common denominator for counting by 5s and 3s because those are a denominator, so we gotta find the first number that they both have. So let's count by 5s. I'll do this in purple. I'll do it right here. So we have 5, 10, 15, 20. And for 3s, we have 3, 6, 9, 12, 15. What number do they both have? 15. So, what I need to do is do what we know how to do best. Turn the fractions into a fraction that has a denominator of 15. So, I'm going to set that up for us, just like so. This should look pretty familiar because we've done it. With a denominator of 15. And remember, we're adding these together. So, 5 times what equals 15? 3. So I gotta put a 3 up here. Remember, this is the whole number. 1 times 3 is 3. 3 times what equals 15? Oh, look, it's already there. 5. So this is gonna be 5 over 5. What's 2 times 5? 10. So I'm adding my fractions together now because it's the same over here. Still adding them. So 3 plus 10, 13 fifteenths. Cannot forget, do not forget your actual whole number that you're adding together, 6. So bringing them together, you have 6 and 13 fifteenths. Just like so. All right. I want you to find part 3 in your workbook. Let's practice these. We'll do probably 2 together, and I'll have you do 1 on your own. So, part 3 in your workbook. Problem A says 10 3/8 plus 2 1/4. Uh-oh, denominators aren't the same again. So, these are like the problems we just worked. I'll read it again for you. 10 3/8 plus 2 1/4. However, the denominators aren't the same. So we need to make them the same, like how we just did it. So first, let's find the common denominator of 4 and 8. Well, this is gonna be kind of easy. 4, 8, and then 8. What's the common denominator? 8. So you are gonna keep these with a denominator of 8. Well, looking at it now, you know 8 times 1 is 8. That's easy. This is going to stay the same. 4 times what equals 8? 1, 2. 4 times 2 equals 8. This is going to be 2 over 2. 1 times 2 is 2. And this is an addition problem. So your answer is going to be 5/8. And then don't forget 10 plus 2, which is 12. So together you have 12 and 5/8. Boom, mic drop. All right, next one, B. You have 9 and 5/6 minus, subtraction, 3/4, 8 and 3/4. So, again, denominators aren't the same. So we need to set that up. So, let's count out. 6, 12, 18. We'll stop there. Let's go with 4s. 4, 8, 12. What do they both have? 12. So, we're going to keep these with a denominator of 12. Easy peasy lemon squeezy. So, let's do what we know how to do best. Multiply. 6 times what equals 12? 1, 2. 6 times 2 equals 12. So this is going to be 2 over 2. 5 times 2 equals 10. And 4 times what equals 12? 1, 2, 3. 4 times 3 equals 12. This is going to be 3 over 3. 3 times 3 is 9. Look, it's already set up. I don't even need to borrow. Subtraction. 10 minus 9, 1. So I have 1/12 over here. What's 9 minus 8? 1. What's my answer? 1 and 1/12. I'm sorry if I went too fast on that. I got really excited. So go back, rewatch it if you need to. This is your key right here, finding the common denominator so you know what to turn the fractions into. It's just counting, skip counting by the numbers you have till both of them match. I counted by 6 here, and I counted by 4s here, until I got the same number for both. And notice, I went 2 spaces here, 6 times 2 is 12. I went 3 spaces here, 4 times 3 is 12. It's all multiplication. So, I'll have you do problem C on your own. Look forward to seeing you do that. So, let's move into unit conversions. So, I'm going to write this on the board. 1 day is 24 hours. The fact shows related units. This fact says 1 day is 24 hours. That's our fact. A fact. 1 day is 24 hours. Are there more days or hours? There are more hours than days. How many times more? 24 times more. So if you change days into hours, do you multiply or divide? If I'm changing days into hours, I'm going to multiply going this way. So what am I going to multiply by? 24. 1 times 24 is 24. So now I'm going to write up here, change 9 days into hours. What's my equation going to be? I'm still moving forward, so I'm replacing 1 with 9. If this one was 1 times 24, this one is going to be 9 times 24. Because now I'm doing 9 days times 24 hours in each of those days. So, work the problem. Pause the video if you need to. You should have 216 hours. Now we're solving. Here's a new one. One year is 12 months. 1 year is 12 months. So, are there more years or months? there's more months. How many times more? 12. So, change 3 years into months. Well, if I know 1 times, this is 1 times 12, I'm just replacing the 1 with a 3. So that's 3 times 12. Pause the video and work the problem. You should have 36 months. THS. All right. Up next. $1 is 4 quarters. $1 is 4 quarters. Read it. $1 is 4 quarters. Are there more dollars or quarters? There's more quarters. How many times more? 4. There's 4 times as many quarters as there is for the single dollar. So we're going to change $12 into quarters. So if this equation is 1 times 4, I'm going to simply replace the 1 with the 12. 12 times 4. Pause the video now and solve. You should have 48 quarters. So open your textbook to lesson 91 and find part 1. You have 3 problems there. Problem A, 1 week is 7 days. Change 11 weeks into days. What do you multiply weeks by to get days? 7. Change 11 weeks into days. Work that problem. Your equation should be 11 times 7. Problem B, 1 year is 12 months. Change 10 years into months. Work that problem. The equation you should have is 10 times 12. Make sure you're labeling your answers. Problem C, 1 hour is 60 minutes. Change 8 hours into minutes. Work the problem. Remember to pause the video if you need to. Your equation for problem C should be 8 times 60. I'm not going to tell you the answers because you should do this on your own. All right, so please continue on to the next video for the next section.